In this video, we're going to use substitution to evaluate a definite integral with trigonometric functions. And they give us the root of, they give us the integral of root pi over 12 to root pi over 9, 5x plus tan to the fourth, 3x squared, secant squared, 3x squared, dx. So what I want to do is I want to figure out what my u value is going to be. So I'm going to say that my u value is going to equal tan of 3x squared. And the reason I choose that is because this is a higher power than the secant squared. And I also know the derivative of tangent would be secant squared, so that should cancel. And 3x squared is a higher power than 5x. When I do the chain rule there, I should end up with canceling that 5x. So I'm going to say u is equal to tan of 3x squared. So the first thing I'll do is I'm going to find the new bound points. And to find those bound points, I'm going to substitute in root of pi over 9 into this x value. So I'm going to say tan of 3 times root pi over 9 squared. So I get u is equal to tan of, if I square the square root, that cancels. So I get 3 times pi over 9, which is 3 pi over 9, which is pi over 3. And the tangent of pi over 3 is root 3. When you do sine divided by cosine at pi over 3, which is 60 degrees. And then if I do the same thing with the root pi over 12, I get tan of 3 times root pi over 12 squared. When I square the square root, it cancels. I get 3 pi over 12, which will end up being tan of pi over 4, which is 1. So my new upper bound, I'm going to call this the upper, is root 3, and my lower is 1. So I'm going to write this as the integral of 1 to root 3. And then I got to substitute u here, so I get 5x. This would be u to the fourth power, secant squared of 3x squared dx. And then I'm going to take the derivative of this u value. So I'm going to say d over dx of u is equal to d over dx of tan 3x squared. So I get du over dx is equal to, derivative of tangent is secant squared, 3x squared, times the derivative of the inside, which is 3x squared. So du over dx is going to equal, I take the derivative of 3x squared, I get 6x, secant squared 3x squared. I'm going to multiply by dx on each side, so I get du equals 6x secant squared 3x squared dx. Then divide this to the other side, so I get du over 6x secant squared 3x squared is equal to dx. I'm going to substitute this piece in for dx here. So I get the integral from 1 to root 3 of 5x u to the fourth secant squared 3x squared all over 1 times dx, which is du, over 6x secant squared of 3x squared. You can see that the secant squareds are going to cancel. The x's will cancel. And I am left with the integral from 1 to root 3 of 5/6, 5 over 6, u to the fourth, du. I find the antiderivative of this, and I get 5/6 u to the fifth over 5 and I'm going to evaluate that from 1 to root 3. The 5's cancel, and I get 1/6 u to the 5th, and that'd be evaluated from 1 to root 3. I start substituting, so I get 1/6 root 3 to the 5th minus 1/6 of 1 to the 5th. So I end up with 1/6. If I switch these exponents out, so I'm going to switch this 1/2 to being outside and the 5 to being on the inside. So I get 1/6 of 3 to the 5th to the 1/2 power minus 1/6. I could rewrite this as 1/6. This would be 3 squared times 3 squared times 3 to the 1/2 power minus 1/6. So then I can take the square root of each 3, and I'll get 1/6 times 3 times 3, and this will just be root of 3 left minus 1/6. So the 3's, this is 9 over 6, so that'd be 3 over 2. So I end up with 3 root 3 over 2 minus 1/6 for my area.